Hello, my name is Deanna Manning, and today I will be discussing the COVID-19 testing procedural changes at Belhaven University. At the beginning of our COVID-19 analysis journey, we used isotemp water baths. The isotemp hot water baths were turned on so that temperature would rise up to 95 degrees Celsius. Warm water from our sinks were also put into the isotemp plate to aid in making the temperature rise. And once the temperature did reach 95 degrees Celsius, the samples were then placed into the hot water bath to thaw for 30 minutes to an hour. And after doing this for 2 weeks, our procedure changed. And our procedure changed because we were having difficulties with time. The sample labels were coming off, and the racks that held our samples were also melting. After this, we then went on to using the Quincy lab drying ovens, and we came to this decision because it saved time in our analysis process. As you can see over here, we put them into these plates and along with some warm water, and it sped up our process of thawing them, and it was still um, very helpful with speeding up our time. And after that, we went on to use the Nova Pro Sous Vide, which is seen over here. And this kept the water at a controlled temperature. So we made it get to 95 degrees Celsius and it stayed there. And we also added more hot water to it just so it could stay warm. And with having this really big cooler, we were able to put 8 racks at a time inside of the cooler, and each rack held 18 rows. And the reason that we changed to this was because we were able to thaw more samples at a time instead of just like 1 or 2. And this version sped up our incubation time a lot. And now I'm going to discuss our -80 thermoscientific freezer. Before using this freezer, we were using a lot of dry ice. Once our saliva samples were collected, we would place them in there, and in order to preserve the saliva, it does a lot better in the -80 freezer. So it takes down, the risk of degradation. And we came to the conclusion with like our data and seeing how good the samples were, even after sitting in the freezer all day, they were still able to be analyzed properly. And now I'm going to discuss the dilution experiment. For this experiment, we began by pulling 2 separate plates that had 2 significant positive samples. One plate was from the -20 freezer on March 3rd, 2021, during our morning lab analysis. And the second plate was from our -80 freezer, and it was in the freezer on March 2nd during the night lab analysis. But both had very known positives. And as you can see in the presence absence plot over here, you can see the positives, which are in blue, and they go above our threshold of 0.200, which allows us to see that they're significantly positive. And even though we diluted each sample like by 1x, 2x, 4x, 6x, 8x, 10x, and 12x, the positives still showed through even though we diluted it more and more each time. Now this next experiment, we're getting the average threshold with our positive samples. And for this experiment, we used 2 known positive samples labeled B2 and B4 from the -80 freezer. And our main goal was to see how diluted a sample could get before it no longer shows up as a positive in the PCR. And as you can see in the data to the right, the presence absence is shown. And we still had the 2 positives that showed up, even though they were diluted, they were very high above our threshold. So it just shows how strong COVID is and how present it is, even if it's masked. Our current COVID-19 analysis procedure, we now use a pooling method as depicted to the right. Whenever one well contains a positive, we'll go back and test the entire row to find the exact positive sample. And with this method, we are able to save time and get an accurate positive sample that reaches the threshold of 0.200. And the reason behind this change is to save us the use of solutions and provide us with clearer and more reliable results. Because with the presence absence data, you're able to pinpoint the positives, even though there aren't positives in this graph, it's very present and very known, just the way that the graph goes. And now I would like to thank my research advisors that are listed here, my laboratory advisor, and our student lab technicians. They've put in a lot of work this semester with helping the COVID-19 analysis at Belhaven University. Thank you, and I hope you enjoyed the presentation.